So in this video we will start chapter number 6, which is the electronic structure of atom, and in this chapter there are 9 topics. Number is wave nature of the light, quantized energy of photons, line spectra and Bohr model, the wave behavior of matter, quantum mechanics, atomic orbitals, representation of orbital, many electron atom, and electronic configuration and periodic table. So in this chapter basically we are going to understand how the electrons are arranged in an atom and what kind of properties they have, which is similar to the light. So two main things we have to consider here. First is the electronic structure of the atom, and that shows the arrangement and energy of the electrons. Second is we will talk about the waves in this chapter, so which is little different than why we are talking about the waves, because the small particle, these electrons have the small particles and they have some properties that can only be explained by the wave manner. So electrons behave like a particle as well as a wave. So why they behave like a wave? Because if we see the electronic structure of the atom, so we know that all the positive charge exists in the center, that is called nucleus, and the electrons or keep moving around the nucleus. So they do not keep moving everywhere, however they have some specific path, so and they move in their specific path, or they are also called cells. So in 20th century discovery, that was the quantum theory. Quantum means a discrete quantity of energy, a fixed quantity of energy. So each cell or each circle have a fixed energy, and the electron are moving in their own. High energy electron will move in like first level of energy, second level of energy, third level of energy and fourth level of energy. So every they move in the different levels of the energy circular pathway. So that is why they behave like a, and this kind of property was explained by the wave nature of electrons. So let's talk about a little bit more about the waves. What are the waves? So we have seen the whenever we touch the water or whenever we disturb the water, some waves generate in the water, and waves represents the energy imparted to the water. To understand the electronic structure of atom, one must understand the nature of electromagnetic radiation, and here we are talking about the electromagnetic radiation. So electromagnetic radiation is also move as a wave through the space at the speed of light. So this is the water wave, and you can see they have high end and lower end. So the distance between the two high end is called wavelength, and the peak value, this is the peak value, and if we put a point here and we have to find out how many waves passes this point in 1 second, so that is called the frequency. And all the electromagnetic radiation move as a wave with the speed of light. So we will understand what is the electromagnetic radiation also, and there are two main important terminology, that is the wavelength and frequency. So the distance between the definition of the wavelength is the distance between the corresponding point on the adjacent wave is the wavelength, and it is represented by lambda. This is the lambda sign. And number of the wavelength per cycle that passes a given point each second is called frequency of the wave. How many time one wavelength or one pass completed by the wavelength, so that is the wave frequency. So if we look at about more little bit about the wave, so you can also write down electromagnetic waves in this fashion, where the one curve line will go on the up, and then same distance will be at the bottom, and then again up, and then again down. So the number of the wave passing a given point per unit of time is called the frequency. So suppose if I put one point here, and how many waves will pass in 1 second from this point, that will be the frequency. And the wave traveling at the same velocity, the longer the wavelength or the smaller frequency. So you can see this wavelength is big, so that is why the frequency will be less, because less wavelength, less number of waves will pass if the wavelengths are the big. However, if the wavelength is small, the distance between the two corresponding point, then the frequency will be high. If we talk about these two, you can see here 3 waves are passing compared to only 2 waves. And if the time associated with the lines to the left is 1 second, then the frequency would be 2 per second and 4 per second respectively. So here we are talking about the if we put the time, then for this figure A, the frequency will be 2 wavelength per second, and for this it will be around 4 wavelength per second. So this is the definition about the frequency. And when we talk about the wave, and then again this slide shows that the longer the wavelength will be, number of frequency will be less. Here this is the short wavelength, this is even longer, so only 2 corresponding points are passing at this place, like this one. Compared to here, you can see how many high points, 1 2 3 4 5, and here is only 2, and here is at least 3. So the number of wavelength will be, if the wavelength will be bigger, the frequency will be less, and if the wavelength is short, then frequency will be high. So it's just opposite in direction. So as we said that waves, electromagnetic radiation behave as a wave. So in this slide they shows that light is a combination of an electric and magnetic field, and which is oscillating very rapidly. It's some alphabets are properties, speed. So very rapidly as it propagating through the space. Light has a property of waves. So this diagram shows that electromagnetic wave have 2 dimensions. Number one vector on the y axis is electric vector, which is going up and down with the red wavelength, and then the magnetic wavelength or magnetic vector is on the z axis, and then it is going back and forth. So what are the electromagnetic radiation? Electromagnetic radiation are called gamma rays, X-rays, UV rays, visible light, which we are seeing, infrared, microwave, and radio waves. So they are all these waves which we seen in and we are using daily in our life, like the light bulb, and sunlight, and because sunlight have UV light and visible light both, and many other wavelength light, and microwave. So they all behave like electromagnetic waves, and they are called electromagnetic wave, and they have two components, which is called electronic wavelength as well as waves as well as magnetic waves. And they move with the same speed of light, which is 3.00 times 10 to the power 8 meter per second, which is very high. And let's see a little bit more about the electromagnetic radiation. This is the scale that shows that wavelength. If you will go from left to right, wavelength is increasing, and from the bottom the frequency is decreasing. So as the wavelength will increase, so you can see gamma rays, X-rays, UV, visible, infrared, microwave, and radio wave. So radio wave have very high wavelength, so less frequency will be there, and X-rays and UV rays and visible rays have less small wavelength compared to radio waves. That is why their frequency is very high. And visible light is the only waveguide, which is the colored spectrum which we see with our eyes, and a display of EMR, which is electromagnetic radiation, in increasing order of the wavelength or decreasing order of the frequency. So this is the display of all the electromagnetic radiations, and all the electromagnetic radiations travel at the same velocity, which is the speed of light, and there is a formula which is called C is equal to lambda and nu. So this is called lambda and nu. Nu is the frequency, represent for frequency, and lambda is for wavelength, C is for speed of light. So there is one more table that is regarding the same electromagnetic radiation, that shows their wavelength in the meters, and then you can see radio waves have the wavelength in kilometers, and X-ray have minus 10 nano angstrom level, UV have -9, which is nanometer. So there are many type of electromagnetic radiation, and they have a different wavelength and energies from the each other. The typical wavelength unit use vary based on the length. So they are all based on their length, which is a number of wavelength. The length represent the wavelength. So again, this slide is important for you to remember the mathematical relationship between the speed of light, wavelength, and frequency. So C is the speed of light, which is 3.0 times 10 to the power 8 meter per second, which is constant, and frequency is represented by nu. It is like a small v, and you can write like this also, small v, nu, and its unit is per second or hertz, and lambda is wavelength. Lambda represent for wavelength, and its unit is in the meter. It can be in the meter or angstrom and kilometers. So this formula is very important for us to remember. And let's talk about one question here. A microwave oven uses a frequency of 2.45 times 10 to the power 9 hertz cycle per second. Calculate the wavelength of the microwave radiation used by the oven. So it's a very common microwave is very common in our kitchen. everyone is using. So if how we can find out how much the wavelength of the microwave would be if we know the hertz. Usually these frequency is written in the back side of the microwave. So how to solve this question? You can see this is given, they have given c, which is a speed of light, sorry, this is frequency. They have given frequency which is nu is 2.45 times 10 is power 9 cycle per second, and c is speed of light, 3.0 here it is written, times 10 is power 8 meter per second. And now they are asking about the wavelength of the microwave. So as I said, that you have to remember this formula either in this form or in this form. C is equal to lambda nu, or nu is equal to lambda over c, or lambda is equal to c over lambda. So whichever you can prefer, you can memorize this formula. So c is equal to lambda nu, and when I will rearrange this one, so lambda will equal to c over nu, and c is the speed of light, 3.0 times 10 is power 8 meter per second, divided by 2.45 times 10 is power 9 cycle per second. So second will be cancelled out, and when we will solve this one, so this will become 3.0 times 10 is power 8 multiplied by 10 is power minus 9 divided by 2.45, and then this will become minus 1. 10 is power 8, 10 is power minus 9, when we will multiply they will become subtract, and this will become minus 1. So 3.0 multiplied by 10 is power minus 1 divided by 2.45, which will be equal to 0.3 divided by 2.45, and let me use the calculator now. So this will become 0.3 divided by 2.45 will equal to 0.122. So this will become 0.122, and the meter unit will be meter per cycle. So this will be the wavelength for the microwave which we use, or the microwave which have the frequency of this one. So this was about the electromagnetic waves and how we can calculate their frequency and with the speed of light. And next we will study about the energy of the waves.